taken geometry. But we're going to add radians to it. Okay. The first thing we need to talk about is the angles of a whole circle. What are the angles of a whole circle? 360. Okay, what is the circumference of a circle? Do we remember the formula? 2 pi r. No, you're putting area and circumference together. 2 pi r. Okay? So, we can write it down somewhere, but you're going to need lots of room for this. So, you can say circumference is 2 pi r. Okay? So, let's say the radius of this is 1, because it's a unit circle, so we're going to use the unit of 1. Unit 1, which equals the radius. So, if I went all the way around the circle, it would be 2 pi, right? So if I went from here all the way around, it's 2 pi, right? Because my radius is 1. So far, so good? Okay. So what would this be? If I went halfway there, it would be what? If all the way around is 2 pi, then right here is just pi, right? And what's half 360, guys? 180. Okay, this is what we're going to start with, where we're talking about degrees and radians. Okay? All right. So we're going to start with picking a color for our one of our central angles. We're going to deal with 36, 45, and 60. I'm going to pick purple for my 30 degrees. Kyle, I've already have to mention your name. Miss Murphy speaking. Yes. Yep. Okay, fine. Okay, so the first thing we're going to deal with is having the best of luck keeping track of my little stuff. Okay, we'll just have to do it this way. All right, so we're going to look at a 30-degree angle first, which is this one. You just draw your line straight from here. You need to make sure it's very exact, which is why I mentioned a straight edge. This is why on the board it said you need a straight edge. Okay, if this is 0 degrees, okay, it's also 0 pi. The distance I went around is only 0. Okay, this is 30 degrees. Okay, this is 30 degrees. The distance in radians I'm going is I'm taking 30 degrees. This is a way to convert degrees to radians. Times pi over 180. Well, I get 30 over 180, or 30 pi over 180. Is there a way to reduce 30 over 180? Could I just stick that in my calculator, ignoring pi?
Yes.
And would I get a fraction, and what would that be? 1 over 6. So I get 1 pi over 6. So I'm just going to change that to pi over 6. That's my radians. Okay. Now I'm going to look at the other 30 degrees. Okay, if I was to take a little triangle of 30 degrees, move from one side, I flip it over, and I get this right over here. So this is on the other side of my y-axis. Okay? If this is 180 and I want to go back 30, how many degrees would that be? 180 minus 30 degrees is how much, guys? 150. 150. Okay? Now, 150 divided by 180, what would that reduce to be?
5/6.
Right, so I have 5 pi over 6. You guys, if you literally stick in your calculator 150 divided by 180, don't put a decimal or anything in there, it will reduce your fraction for you. So it's 5/6 pi. Okay, then we're going to flip this over the x-axis. Okay, 180 plus 30 more is how much, guys? 180 plus 30 more is how much? 210. Okay, 210 over 180 reduces to what?
7/6.
So it's 7 pi over 6. Okay, and then we've got this last one right here. Okay, I like to think of this as 360, right? Because this is also 360 degrees. 360 minus 30 gives me how much right here? 330. And 330 divided by 180 gives us 11 pi over 6. Radian of the degrees of the circle. Radians are just a different form like degrees. So remember I talked to you about this is a radius of 1. Okay? So the circumference of my whole thing is 2 pi r. And if we replace r with 1, we get 2 pi. So this distance is 2 pi. So this distance from here to here, half of 2 pi is just pi. Now this distance from here to here is pi over 6. If I go from here all the way to here, I get 5 pi over 6. That part. Questions? Okay, now you're going to do some of this. We've done the 30 degrees. Next you're going to do, we've got a different color. So I'm going to go to the top and mark this orange. And I'm going to draw in my 45 degrees. Okay, so this is 45 degrees, and I'm going to let you guys figure out the radians and figure out the other 45 degrees. Then this, my final color I'm going to choose is the green. here is going to be 60 degrees, and I'm going to have you guys figure out the radians for that. Before we move on, though, I'm going to figure out this angle is right here is going to be what? Right here. Anybody? From here to here? 90 degrees. And if this whole thing is pi, what's here going to be? I'm how far to pi? Half of it. So pi times 1/2 is pi over 2, right? Now I'm going to do way down at the bottom. If I go 0 to 90, 90 to 180, 180 to... No. In between 180 and 360 is 270. Okay? And the radians for, excuse me, this is being recorded. Be appropriate. If this is 270, 270 divided by 180 is 3 over 2, so that's 3 pi over 2. You're going to do all the 45s. There's 4 of them. All the 60s. Do 4 of them. Before I move on, because there's one other thing I want to talk to you about with this. Okay. With a 30, 60, 90 triangle, okay, if this is my hypotenuse of that angle, let's just look at the purple one. If my hypotenuse is 1, what would my other sides be? This is 30 degrees right here. So, and this is my 90 degrees, and this is my 60 degrees, correct? My hypotenuse is 1, so what's my smallest side going to be? My length of my smallest side. It would be 1/2. And this would be square root 3 over 2, right? Because of the special 30, 60, 90 triangles. So I would have square root 3 over 2, comma 1/2. Okay? I mean, you're going to have this sheet, and you're going to have to fill it all out. So the important thing for this, my x values, when we're looking at sine, cosine, and tangent, just the trick. Cosine deals with your x values. Sine deals with your y values. And that makes sense, right? Cosine, x, sine. So this right here is my cosine for this angle. This is my sine. All right. You need to do the 45 for all of them, 60 for all of them, and I would like you to attempt to find these for a 45, 45, 90 triangle. So I'm going to leave a space because you need your radian. If this was 1 right here, what would these two sides be? If that was 1. So let's look at a 45, 45, 90 again. Okay, so here I have a 45, 45, 90 degrees. You need to pay attention. We know these two legs are x, and the hypotenuse is x, square root 2 is big, correct? Okay, so we are replacing our unit circle and saying this is 1. How am I going to figure out the two lengths of my special right triangle? 1 equals this, correct? How do I get rid of that square root 2 so I just have x all by itself, guys? No. X is being times by the square root of 2. What's the opposite of multiplication? Division. I divide both sides by the square root of 2. 1 square root 2 equals x. Can I have a square root on the bottom? No. So I multiply the top and bottom by square root 2. And I get square root 2 over 2 times 2 is square root of 4 is 2. So for 45, I get square root 2 over 2, comma, square root 2 over 2. This might be something you want to draw at the very bottom of your unit circle where you have room. Let's draw it in a 45, 45, 90 triangle. This is 1. These are square root 2 over 2. A 30, 60, 90 triangle. The hypotenuse is still 1, but across from 30 is 1/2. Across from 60 is square root 3 over 2. Just remember, when I change the direction of my triangle and put 30 degrees at the top instead of the bottom, there's still a cross. Across from 60 is still square root 3 over 2. Across from 30 is still 1/2. Yeah, and I'm going to leave these on the board. I'm going to come around and check as you try to find your radians and your degrees for your 45 all the way around, your 60 all the way around, and then find your sine and cosine for your x and y coordinates.